All right, today we are diving into something really cool, a new candidate for dark matter. But here's the twist. This isn't about finding a new particle. It's about building one, right from scratch, using just the fundamental rules of a theoretical, kind of pixelated spacetime. We're going to be talking about the Aetheron.
So let's kick things off with a big question, one that really shapes this whole idea. What if dark matter isn't some exotic, undiscovered thing we have to add to the universe, right? What if it's just a new pattern, something that just pops out of the very fabric of space-time itself, made from the same basic stuff as everything we see?
Okay, to really get our heads around this, we have to start with the basics, the architectural blueprint. Before we can even think about building the Aetheron, we've got to understand the rules of the game, the theoretical universe it lives in. It's like learning the physics of a video game before you can play.
And this universe is run by something called a twist operator system. Now think of it like the code of a game engine. You've got a map, which is this discrete graph of points. You've got rules for how things move around. Those are the transport operators. And then you've got a special move, the inversion operator. That's it. Those are all the tools in our toolbox.
And here's where it gets really mind-bending. In this model, what even is a particle? Well, it's not a tiny little dot. A particle is a behavior. It's a stable, repeating path, a loop, that just keeps traveling along that graph. It's a pattern of movement, not a static thing.
Okay, so if particles are just patterns, where does mass come from? It's not something they're just born with. In this model, mass, it just kind of emerges whenever a particle's orbit gets snagged just for a moment by that special inversion operator we talked about. These little inversion stalls, that's what gives an orbit the property we feel as mass. So more stalls, more mass. Simple as that.
And charge? Well, it's a very similar story. It's not some little plus or minus sign glued onto a particle. Nope, it's a geometric thing. It all comes down to the shape of the orbit's path. Is it winding to the left or is it winding to the right? This handedness, or chirality to use the technical term, is what decides its charge.
All right, so we've got our rule book, we've got our building blocks. Now comes the fun part. We get to put on our engineering hats and see how these pieces actually come together to build this ghost particle. Let's assemble the Aetheron.
And this right here is the blueprint. I know, it looks super simple, but trust me, it's incredibly powerful. It tells us that our Aetheron, which is gamma A, is built from two pieces, a loop with positive handedness, gamma plus, and one with negative handedness, gamma minus. And that little symbol in the middle, that's the secret sauce.
So let's walk through it. First, you take one of those right-handed loops. That gives you a positive charge. Then you grab a left-handed loop, which gives you a negative charge. But, and this is key, you don't just set them next to each other. That symbol, the number sign, means we have to topologically link them. Think of two links in a chain that can't be pulled apart. And when you do that, you get this. Once they're linked, they stop being two separate orbits. They become one single unified thing, a composite orbit that you just can't break apart. And this new entity, that is the Aetheron.
Okay, so we built it. The big question is, does it actually work? I mean, the very first test any dark matter candidate has to pass is being electrically neutral. So according to our own rules, does the Aetheron's total charge really add up to zero?
And that question brings us to, let's call it, the quality control phase. We've got our blueprint, we've built the prototype, now it's time to run it through the official dark matter checklist and see if our design actually meets the specs.
First up on the list, it absolutely has to be electrically neutral. I mean, we know dark matter doesn't play with light, so it can't have an electric charge. It's the most fundamental, non-negotiable requirement.
And look at that! Our Aetheron passes with flying colors. It's almost too easy, because charge is just a measure of that geometric winding, right? And we've perfectly balanced a right-handed loop with a left-handed one. So they just cancel each other out. The combined orbit has a net handedness of 0. Which means its net charge is 0. Check 1.
Okay, next on the list, stability. If you're going to make up like a quarter of the entire universe, you can't be falling apart. Dark matter has to be incredibly stable. We're talking stable over billions of years.
And this is where tautology becomes our best friend. It's our guarantee. See, this linking number is basically a mathematical way of saying how tangled up the two loops are. And as long as that number isn't 0, meaning they really are linked like a chain, the orbit simply cannot split. It's against the rules of the system. It is locked in. It's stable. So check.
All right, property number 3. This one's a biggie. we have to talk about mass. The whole reason we even think dark matter exists is because of its gravity. And to pull on things with gravity, you gotta have mass. So, does our Aetheron have any weight?
And here's the thing. Not only does it have mass, it has to. The proof is actually really elegant. Think about it. If the Aetheron had zero mass, that would mean it has zero inversion stalls. But for that to be true, the loops would have to be lined up in a really simple way, a way that would let them just come apart. But wait, we just proved they can't come apart because they're topologically linked. It's a contradiction. The only way to solve it is that the Aetheron must have those stalls, and therefore it must have mass. Its mass is literally a consequence of its own stability. How cool is that?
And finally, we get to the one in the name itself. It's called dark matter for a reason. It has to be invisible. So, does our Aetheron fit the bill? Why can't we see this thing?
Well, it turns out the same trick that made it neutral also makes it dark. It's beautiful. Those two subloops, with their opposite-handedness, are creating these opposing currents. So when you zoom out and look at the particle as a whole, these currents create fields that just perfectly cancel each other out. The net result? It has basically zero coupling to photons, the particles of light. It's literally invisible to light.
So, let's look at the final scorecard. Neutral? Check. Stable? You bet. Massive? Absolutely. Weakly interacting and invisible to light? Yep, check and check. The Aetheron, a particle we literally built just from the rules of space-time geometry, has aced every single test on the dark matter checklist. So, what does all this actually mean? Okay, it passed the tests, but what's the bigger picture here? What does the Aetheron, if it's right, tell us about the nature of reality itself?
This, right here, is the really profound part, the big takeaway. Dark matter might not be some new ingredient you have to dump into the cosmic recipe. It could just be a different, more complex arrangement, a stable topological knot, made from the very same fundamental dynamics that create the protons and electrons we see all around us. It's not new stuff. It's just the old stuff woven into a new pattern.
And that just leaves us with this one final mind-bending thought. If a mystery as huge as dark matter can be explained not by a new thing, but by a new pattern in the fabric of space-time, it just makes you wonder, right? What other massive secrets are hiding, not out there in some distant galaxy, but right here, in the very structure of reality itself?